Hello, today I will be presenting my case study titled Corrosion of Infrastructure, the Gardiner Expressway. This presentation will explore the impacts, causes, and solutions to corrosion affecting one of Toronto's most important transportation structures, the Gardiner Expressway. So to start with some general concerns. So the Gardiner Expressway is a vital east to west route for commuters, freight, and emergency services in Toronto. However, after more than 60 years of exposure to harsh environmental conditions and winter road salts, the structure has undergone extensive deterioration. Chloride-induced corrosion has led to visible spalling, cracking, and exposed reinforcing steel, posing serious public safety hazards, such as falling concrete. To address this, the City of Toronto has chosen rehabilitation over demolition, a decision made to maintain essential traffic flow while also extending the bridge's service life. So some of the human aspects from the corrosion of this Gardiner is falling concrete incidents, which has raised public concern and eroded confidence in the structure's safety. Repair crews have also faced dangerous conditions while performing maintenance under unstable conditions. Politically, there's been strong divide calling between those who request its demolition versus those who want it um, based on the economic necessity of keeping it operational. Residents and businesses also continue to deal with construction noise, dust, and traffic disruptions while this rehabilitation is going on. So some of the economic aspects um, has have strained the city of Toronto. For example, in the 1980s, the annual maintenance costs were around $8 million, but by 2011, they had risen to $12 million. The strategic rehabilitation plan introduced between 2014 and 2016 is expected to cover the cost over three is expected to cost over $3 billion to access across the 2 decades. To control costs and minimize disruption, engineers have adopted the accelerated bridge construction technique, which uses prefabricated components to reduce closure times. Despite the expense, rehabilitation remains more cost-effective than demolition, as closing the entire highway would have a far greater impact on the productivity of the city's economy. The root of this problem lies in the chemistry of corrosion. De-icing salts, mainly sodium chloride and calcium chloride, penetrate the concrete through pores and cracks. Once inside, the chlorine ions destroy the thin passive oxide layer that normally protects steel. This initiates an anodic and cathodic reactions, where iron oxidizes Fe2 plus and reacts with oxygen and water to form hydroxides. The resulting rust and iron oxides can expand up to 6 times larger than the original steel, creating internal pressure and cracks that surround the concrete. Patch repairs often make the problem worse by introducing incipient anodes, where new concrete accelerated corrosion in adjacent older section. To combat these issues, several engineering solutions have been implemented. First, accelerated bridge construction allows prefabricated deck units to be installed quickly, minimizing traffic closures. Second, galvanic encasement uses sacrificial zinc anodes embedded in concrete to protect reinforcing steel from oxidation. And thirdly, the high-performance self-consolidating concrete improves durability and bonding. Additionally, joints and drainage systems have been redesigned to prevent chloride infiltration, which is one of the primary corrosion pathways. While alternatives such as stainless steel reinforcements or compressed current cathodic protection were evaluated, they were deemed too costly for large-scale implementation. Corrosion and road maintenance activities have also had environmental implications. Runoff from the Gardiner carries chloride, iron, and zinc and concrete particles into nearby waterways, including Lake Ontario and the Don River. These pollutants affect aquatic life and contribute to long-term ecosystem degradation. To mitigate this, Toronto's rehabilitation program includes enhanced drainage systems, system runoffs, capture basins, and better salt management strategies. Although road salts cannot be completely eliminated in Canadian winters, optimizing its application can significantly reduce environmental damage while maintaining road safety. In summary, the Expressway demonstrates how corrosion is both a technical and societal challenge. Chemically, chloride-induced corrosion of steel reinforcements remains the key cause of damage. Technically, the city has implemented long-term solutions like galvanic encasement, accelerated bridge construction, and drainage redesign to extend the structure's lifespan. Economically and environmentally, these solutions strike a balance between cost and efficiency and public safety and sustainability. Ultimately, the Gardiner serves as a reminder that successful infrastructure rehabilitation requires collaboration between engineers, policymakers, and the public to ensure resilience for generations to come. Thank you.